of the midterm report. So we might start report maybe next week, but today it depends on today's progress. So I still need to take, because we still have one chapter for nthu-nanomaterial. So I may need to take 3 or 2 class. So might be, okay, just make sure you guys have ready, okay? Just ready and next week. Okay, but I still may need to take 2 class to finish the chapter 8. Okay, so in case of the, for example, next week we finish our old class and then we start presentation. It's okay? Okay? So please make sure you have to ready. This is the list of the first week. All right? The first week. So remember about your name. Okay, here. And Sabisha, also please also send this to student. Okay. And then this is another week. Okay, in another week we have 25 people, so maybe we need to take 2 to 3 weeks. Okay, 2 to 3 weeks. So till end of December, and then we finish all the class. Okay, we finish all the class, and in the January of the second week. Okay, the second week of the January, we will have final exam. Okay, final exam. So the final exam will be from chapter 5 to chapter 8. Okay, 4 chapter. And today I will give you guys about the midterm exam. The scope is quite high, so might be very easy. Huh? Okay, so now we switch to the chapter 7. Regarding last week, we have talked about the piezo electrical nano generator, and today we will finish this chapter. And last time we know the piezo potential, right? We know the piezo potential of one of the materials. So this is just take one of the ferroelectrical AVO3 materials, which is the micro wire. So based on the theoretical calculation, as long as there is a ferroelectric or piezoelectrical materials, so they have the piezo potential. So the piezo potential being created should be aligned with the polarization axis. Okay. So what is the polarization axis? It is determined by the cation and anion shift, right? If there is a cation and anion shift, so-called off center, okay, is not at the center position, like the PDT. Last week we have talked about the PDT, right? Then zirconium titanium oxide. So there's a titanium and zirconium. There's off center. So create polarization. For example, this is a zinc tin oxide. These materials also has a long-central image aligned with z-axis. As you can see, the tin, zinc and tin is not at the center position. So accordingly, you will create a polarization aligned with this. But for the x direction and y direction, there's no polarization because there's no off center, right? So polarization and piezo potential is only created, okay, at the deviation, okay, the atomic, the atom deviation, okay. So therefore, this is a simulation that tells us because actually this is based on the final element simulation. You have the piezo potential, this material's piezoelectric coefficient. So we can plot this array piezoelectric coefficients to calculate the piezo potential. Okay. Regarding the detail of the final element, because this is out of the scope of our course, so we don't explain about more detail about that because this is relative to the calculation. Okay, relative to calculation. But anyway, as long as the material has a piezoelectric materials, you should be able to find out the polarization. Okay, the polarization this material is aligned with the d-axis. Okay, same as PDT. Okay, so we have explained about this mechanism, right? We have explained about this mechanism, and actually there's a single site because based on the single microbarrel nano generator, we can see we modulate, we pick up one single microwire on the PS substrate, so align with this direction. So once we bend it, okay, upward, downward bending, and there's a tensile strength. Upward bending, there is a compressive strength. So the compress and tensile strength, the signal will be opposite, okay, because the polarization will be different, okay. So this is IV curve tells us that last week we have talked about that this is a single site because here is a 0, right? And here is a 0. So you can see here for the left-hand side is only single site Schottky bearing. Okay, Schottky bearing height. So accordingly, you can see the single site Schottky bearing being established based on the original position. There's no strength. Okay, so once we apply the strength, because based on our calculation, we know that there's a piezo potential. So should be established one side piezo potential. So you also can assuming this piezo potential can be located on the right hand side as well. But now we assuming the piezo potential is on the left hand side. The same result, okay, same result. So therefore you can see once we bend it, and then you can see the piezo potential being established. So therefore the conduction band, the carrier of the electron will float. Because here, the original position is right here, but at this moment be left up, right? So therefore, the electron will be flow out through the external load. So the external load could be an IV measurement, so you should be able to get the electricity. So therefore, you have the electricity, and then the electron will accumulate because here is the Schottky very high, so the electron only accumulate on the right hand side, okay, on the right hand side. So therefore, once you release, okay, then the piezo potential suddenly disappear, right? So therefore, suddenly disappear. So therefore, this position will be much lower than the right hand side. So therefore, the originally accumulated over the electron on the right hand side will flow back, right? Will flow back. So the external load will measure the electricity. So that's why you can get upper circuit and lower electricity. This is because of the electron flow one side to the right hand side and flow back, right? So therefore you have opposite current output, okay, current output. So that's the main mechanism. So based on this mechanism and all the piezoelectric nano generator, you always get the AC signal, right? AC signal, right? So if we want to utilize this, we can use the AC-DC converter. You can use the AC-DC converter, right? To convert, we know about the chapter 1 or chapter 2, right? Chapter 2. Sorry, chapter 3, we have discussed about rectifier circuit, right? The rectifier circuits can convert the AC signal to the DC, okay, to the DC. So you can get such a signal, okay? And then now it is very simple to tell us that if we bending it stronger, that you bend it stronger, AC signal will be generally higher. Okay, it depends on the bending force, right? The bending force. So that's why this can be used as a force sensor, right? As a force sensor. For example, you slightly bending, you get slightly output. You strongly bending, right? You get strongly output, right? So accordingly, you can calculate about the deviation, right? You can calculate about the device deviation, okay? The curvature, and then you can have the linear curve, right? You get the linear curve, such as bending deviation as a function of the output electricity. You know what I mean? For example, this is the output, like a current or voltage, okay? And then you have you could using a force. This can be Newton, calculate the force, right? Or like a stress. You just determine what quantity you want to evaluate. You can also evaluate about strength. Right? Strength, because you can calculate about once I apply a force, right? So I can measure about the force in bending, right? So you can apply the force here, or if you want to calculate, okay, based on this deviation and then how much strength being generated, right? So you can apply the strength here, right? So therefore, you could have the output voltage. For example, this is right here, right here, right? And then you have a curve, right? You get this curve. Okay? So you get this curve, and there's a difference quantity of the force and stress and or strength, and there's some relative output electricity. So based on this device, so you can use this device to do some calculation. So finally, you get a calculation because different device could have different curve, right? It depends on the device, right? So you can write something like write a software, okay, and so-called linear software, okay. In the Chinese, so-called 演算法, okay. So-called you can write a software to match this curve. So after, for example, this device being measured 10 volt, and you will have 10 volt is corresponding to 10 Newton, for example. Okay, for example, 10 volts. If the device gets 10 volts, if the device gets 5 volts, and corresponding to 5 Newton, and I know now the force has been applied 5 Newtons, something like that. So this is it's a particularly like you can take very high sensitivity of the force sensor, and then there's no external power source being applied because we don't apply any battery, right? No battery, because this is self power, right? Self generate electricity, so-called self power. Self power sensor. Because no external battery being applied, right? Okay, so the same situation that this is that we have talked about using the piezoelectrical materials or ferroelectrical materials. We can be successful to apply such self power sensor. Okay, and another is this is the last section of this chapter. I want to talk about the tribal electrical generator. This is also self power, okay, but different mechanism. Okay, different mechanism. For the piezoelectric materials, the major mechanism, as I mentioned above, is the polarization, right? Is the deviation, right? Because the cation, anion, there's a deviation, so create a polarization. Okay, so as long as you apply the strength on it, so you should be able to generate electricity because the deviation will resist the force. So therefore create a dipole moment. Okay, this dipole moment we call the electrical dipole. Okay, electrical dipole, 电偶极. Okay, electrical dipole. So 电偶极 or electrical dipole is some kind of electricity. Okay, but for the triple electrical materials, inhibit, okay, exist all the materials, Any material you tell me there's any material has a triple electricity. Okay, in your body, you have the hair, you have the hand, you have the tactile, you have the tissue, right? All the materials have a triple electricity. For example, your hair, okay, your hair. You know about your hair carried by positive charge or negative charge? Positive, yeah. What we call the positive charge? Positive charge, that means the material is easy to donate the electron to some substance. Negative charge, like some clothes or plastic. Okay, plastic carries a negative charge because the plastic is easy to get the electron. Okay, so like the metal. Okay, metal has an electron cloud. So metal is carried by positive charge because metal is easy to send the electron to someone. Okay, to someone. So mostly, like as long as you have a positive charge, you have a negative charge, and put them together, you will get the electricity. Just like now is the winter season, right? And then if you ride a vehicle, inside of the vehicle. For example, you take the bus, right? You take the bus and then take to the Taipei, take for 1 hour, okay? And then you get off, right? As long as your hand touch the bus, the door of the bus, maybe you get shock, right? This is because of the bus surface being coated something like past, like 油漆要怎么讲 ？Like some past, like some of the, in a vehicle there's a deposit. In the vehicle they deposit something like a plastic or something like a glue and past, right? Usually this kind of the materials is polymer, okay, like a polymer. Okay, this polymer carry negative charge, but your hand is carried by positive charge. So because this bus is travel in the air, okay, air for a long time, for 1 hour, and air is a positive, air, air is positive. Vehicle surface is negative, right? So they friction for the 1 hour. So that means that the surface, you could see this vehicle carry strongly negative charge, right? And your hand is a positive charge. Okay? So therefore, negative, positive, in general electricity. Okay, so that's why some of the vehicle, they has a ground, need to ground, right? Because have to screen off the charge on each surface, okay, on each surface. But it depends on someone. For example, your friend, hey, I don't have such experience. But someone feel, oh, I have very frequency experience. Why? Because someone's body is different, right? For me, maybe I carry more positive charge. For you, maybe you carry less, right? So you should be okay, but someone should be different, right? So it depends on the situation of the people, right? Of the people. So accordingly, this is quite interesting phenomenon, right? And has been developed, has been discovered, I would say, has been discovered over than, I think, over 100 years, right? Over 100 years. But there's only well-known, this is a well-known tribal electricity. But up to now, I would say, because this is the only one discovered in 2012. 2012, they discovered tribal electricity using the sensor, okay, use the tribal electricity phenomena to produce the tribal electrical nanogenerator. So I would say recently 10 years just been addressed, okay, especially recently 10 years. So maybe now it's become a big field to develop, to discover a lot of the application, okay, not only the sensor, but also they have created a lot of the scenario and application, like a force sensor on the chute, and also they can sell power using ocean wave. Okay, you know the ocean wave. There's a tide, right? Tide wave. Tide wave, as I just mentioned, that every minute, every second produce tide wave, right? But we don't have such a device to utilize such a tide wave, right? So far, we don't have such a device. So they have discovered a lot of application that maybe sooner or one day it is possible that in addition to the solar cell photovoltaic, to harvest the solar light, and then there's a tide wave, right? Ocean wave. When we don't have the sunshine, right? And then in the day, in the night, they still have some device can harvest, continue to harvest the electricity, right? So that's very important for the people to understand, to do our best to utilize all the possibility in the earth, right? Energy, okay, energy. So this is the idea, okay, it's the idea. So just I mentioned, okay, positive charge, negative charge, okay, is unbalanced. So all the substance maintain a neutrality. So this is depends on, later on I will show you about the mechanism, okay, the mechanism, because all the substance need to maintain the charge neutral, okay, charge neutral. So charge neutral, so accordingly, there's has a positive charge and negative charge generated. This is also, as I mentioned last week, right? There's a polarization, okay, S. So this S is a static charge, okay, static. D is equal to epsilon and epsilon zero, epsilon E. This is E. This is electrical field. And then polarization, right? And still there is a small term, it's a PS, right? For the piezoelectrical materials, this term we call the polarization. For PENG, PENG that means PENG is abbreviation of the okay, piezoelectrical energy. But now, for this term, PS is a static charge. And you say electrical static. Electrical static charge for TENG. Sorry. TNG, so-called new generator is the NG. Okay. So it's also something like electrical charge. You can also think about the polarization. Okay, it's one of the polarization relative to electrical static charge. Is that okay? Polarization. You can treat this as also one of the polarization. Okay. Result from electrostatic静电的 charge. Okay, electrostatic charge. And this polarization is relative to the piezoelectric charge, dipole moment. Okay, this polarization. Due to non-central symmetry structure. Okay? Due to non-central symmetry structure. Piezoelectric. Non-central symmetry. We already explained about it. Right? This is non-central. Non-central doesn't mean it's not at the center, right? It's not at the center. The atom is not at the center. So this is a non-central. So here, if you want to know about, Professor, or where can I find about the materials, right? You can type in the Google, just tribal electrical series table. Okay, tribal electrical series table. You should be able to find a lot of the materials produced here, right? Because I just mentioned air, right? Air is the air, right? Air is positive, right? So if you boil the air on some surface, create a positive charge, right? And you can select polyester, right? Polyester, some polymer materials all on the right hand side. Polyester, PET, PP, PS, poly something, anyway, all on the right hand side. So the mostly negative charge will be Teflon. Okay, Teflon is the most, because the Teflon, there's an atom of fluorine. Fluorine has a mostly negative charge. Okay, fluorine. Fluorine is on the periodical table is on the right hand side, right? On the right hand side, right? The mostly the right hand side. So therefore you carry negative charge. So if you want to build up a sample, that's very easy. You just having a hand and a Teflon friction together. You will generate electricity. Yeah, very easy. Okay. But now is how to become a real thing, so-called a real sample that can be commercialized, right? That become meaningful, right? If you just demonstrate, oh, that's electricity, right? There's no meaningful, right? Because this is a physical meaning, right? Physical phenomena, right? We know about that. But the most important is how to make the device can be commercialized, can be stabilized, can be reliable enough, right? That's very important. That's as a scientist, okay, as a scientist, as a material scientist, you should be able to know about that. Okay, this is last time I have invited Zhong Liwang to our department. We have MISTIC, right? Last week, I think it's 2 weeks. It's 2 weeks ago, right? 2 weeks. He has present mostly recent work. Okay. Let me show you about this video taken from him.
We are in the School of Material Science Engineering, Georgia Tech. We have invented a new energy technology. I believe that's going to change the world in the near future. We are in the School of Material Science Engineering, Georgia Tech. We have invented a new energy technology. I believe that's going to change the world we live in the near future. We look for new energy, but energy is around us, everywhere, all the time. But most time we waste it. Until recently we find this can be a very important fact for energy. Now how does it work? So what you see here is A materials and B material. When they become physically contact, there's a charge transfer. If they are separate by a gap, there's a voltage generated. The second mode is sliding. If you have two materials, they slide one against the other one. You can also have a charge here. One mode is physical contact, and the other one is sliding. These are the two basic modes we use for electricity generation. This is called trouble electrification, or scientifically called contact electrification. And this occurs for almost any materials we know today. Why do we use nanomaterials here? By using nanostructure on the surface, we can largely increase the surface area and hugely enhance the charge transfer. Without use the pattern, with use the pattern, the power density is different by 1,000 times. When we first invented this was fall of 2011, the output was just 3 volts. Today, our best can be 10,000 volts. Mechanical energy is everywhere, independent of weather, independent of day or night, independent of season. So anything you can think of, smaller scale from finger tapping, from your touchpad, from the walking to car motion, even train motions, we can do that. We harvest energy we have been wasted for years. We never use them. So I anticipate this can not only contribute the power source for portable electronics, but also can contribute power source for large scope of energy need. It can contribute significantly to the worldwide energy need in the near future. And we even think for big ocean wave, theoretically, let's say 31 terawatt energy can be harvested. That's twice of today's world energy consumption. It will not take too long, 5 years.
Yeah, so this is a demonstration. There's a many demonstrations. So based on what time? 14. Okay. So based on the mechanism, so there's a four mechanism actually. So this is the vertical contact, okay, vertical contact, and contact slightly mode, okay, slightly, and also single electron mode, okay, single electron mode. Single electron mode, that means that you just need to provide one electron, okay, one electron. Another electron, you just need to provide the, for example, the one side positive charge, another side you provide negative charge, right? So you can provide the single electron mode. And the single electron mode, you can depend on, you can use the, like a force pad and just browse. Okay, looks like you can browse the laptop or the iPhone or the cell phone. And also freestanding tribal electrical layer mode. Okay, all actually are the same mechanism like because of the friction. So later on I will show you about the vertical contact mode. Okay, vertical contact mode. So here is the demonstration of the single electron mode. Okay, let me show you. Actually, single electron mode and vertical contact mode is the same. Okay, it's the same. Let's look about the vertical contact mode. Each side, each electron we deposit an electron, okay, metal electron, and this is also a metal electron, copper. Okay, for example, you have the one side one materials carry. This is the positive. Okay, another side. Carry negative, okay, negative. And then if we connect both sides to the IV measurement systems, this can be also called load, which means external load. Right, external load. Okay, for example, they both, the first stage, they contact each other. So at this moment, they maintain the charge neutrality, right? Charge neutrality. Okay, this is charge neutrality because balance, positive and negative balance. And then once they separate, separate. You will see this is a positive. Create a distance. So start from now. This part, the upper part and lower part, need to maintain the charge neutrality as well, right? Because they start to separate. So in this part, you could see, oh, because this part need to maintain charge neutrality. This part also as well. So therefore, you will see there's a electron flow on bottom side to lower side. Right? And then here, you will see you have to be very careful to here. This is a negative, negative, negative. Right? This is the first step. This is the second step. And because now flow 3 electrons to here, right? So that means because the metal, this copper donate 3 electrons out. So that means carry become 3 positive charge, right? Because the copper donate 3 electrons. So which means the positive charge carry becomes 3 positive charge, right? Because this should be balanced, right? So next step, once this distance become larger, okay, become more large, so-called at the D maximum, for example. So it is D maximum. At the D maximum, that means that this part and this part already no influence. Okay, no influence each other. So all this part need to maintain charge neutrality. Upper part needs to maintain charge neutrality. So therefore, here the electron will be 1, 2, 3, 4, 5, 6, 7, right? So and then the copper, because this copper donates 7 electrons out. So therefore, this copper will carry 7 positive charge on each cell. Is that okay? Right? So same situation. This is D maximum. And once do this is 3, and then 4 step. Once it close, close. That means it become to D, okay? Come to D, so we will get here is copper, here is copper. So once it closes, so the upper part and lower part will start to influence each other. Upper surface positive, lower part surface negative will start to influence each other. Do you understand what I mean? So therefore, at the bottom side of the original negative charge, here the electron will flow back, right? Or flow back, which means there's a three electron flow out, right? 3 electron flow out. So that means that there's a 3 electron flow out to here, and then 3 electron flow out. That means here will become negative, become the positive, right? Because the 3 electron flow out, right? And 3 electron flow out, flow to here. The originally right here is 1, 2, 3, 4, 5, 6, 7, right? And then the electron will cancel out here, right? The original was 7 holes right here, the bottom side, right? But the 3 electron flow to here, so therefore 3 positive will be cancelled out. Is that okay? Okay. And finally, become the first step. They touch together. They touch together again. So here will be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Electron. 7 electrons flow out, right? So therefore, 7 electrons flow out to cancel all the electrons, all the 7 electrons, right? So the bottom side positive charge will maintain 0. Bottom side electron, is called. Because now the top and bottom side surface already become the charge neutrality. So no more of the positive and negative on the copper electron. Is that okay? Right? Because all the electrons, so in here, all the electrons cancel out. Back to here. Right? Okay, let me explain again and then we take a break. Okay? You just remember about all the substance need to maintain the charge neutrality. So therefore, here, because they pack together, so we can regrade this as a single part, one single part. So single part, positive, negative, so charge neutrality. But once we separate to slightly distance b, so here is positive, here is negative. So in order to maintain upper and lower part a charge neutrality as well, so therefore here the electron will be flow out. That means the copper will donate the electron, right? Donate the electron. Donate the electron to the upper parts, right? So they donate the electron, that means they remain, they carry positive charge. For example, 3 positive, and then 3 negative to here, right? 3 negative. This is the one to make the upper part become charge neutrality. So finally, up to the D maxima. So this surface and this surface no longer have some relative, no any relative, no influence. So upper part you can regrade. There's two parts. You have top part and bottom part. All the parts need to maintain charge neutrality. So that's why there's a 7 positive and behind electron with a 7 negative. 7 negative and behind of the electron with a 7 positive. Electron flow to be electron. And then once we close again, okay, because this part and this part surface will start to inflate, again. So therefore, the electron will flow back. Once the electron flow back, that means the electron will cancel out here the positive, right? Here is negative, part is a positive. So once the 3 electrons flow to here, so there's no electron, right? No electron. And then once they come back together, and this will become a charge neutrality. Okay, so I would say charge neutrality all the time. Charge neutrality all the time. Okay, for all the time. Charge neutrality. This is the charge neutrality, right? This is the charge neutrality, and this is the transition state of the charge neutrality. Is that okay? It's a transition state. So you have to be very careful about the number of the positive and negative on the electron. Because the last time I have a final exam to show you about this, and then people just write, okay, positive, negative, positive, negative, and the number doesn't make sense, right? You have to maintain the same number. Do you understand? Yeah, because right here there's a 3 positive, 3 negative sent out. But here have a 3 positive, right? Here should be 3 positive. And once it right to the 4th step, right? 3 electron flow out to cancel 3 positive. Right now will maintain 4 positive, right? Because 3 positive be cancel out by electron, right? So you should be maintain the 4 electron, 4 hole. Sorry, 4 hole, 4 positive. And finally, we come to the first step. Okay, this is 5 step. 5 step also the first step. 5 step is the first step. Okay, you can treat this back to here and back to here, but the electron will flow back. Electron will flow back. Okay, let's take a break. Okay, take a break.